There are several demos that I prepared in order to show you how PE-sieve works in action. So on this machine, I have PE-sieve, the latest version, and also some PE-sieve based tools such as Holes Hunter and Malanpack. And I also have several samples on which I will demonstrate its capabilities. So let's start from some basic example. Here I have two applications that are non-malicious, and that they are both packed with the help of techniques that are commonly used by malware for process impersonation. One is packed using run-PE technique, which is also known as process hollowing, and the other is packed using process doppelganging. So let me start first of them. As we can see, the injector shows that Windows calc has been impersonated and a payload has been injected there. So this is the injected payload, and we can see that it is seen as, it runs as a Windows calc. So let me now start PE-sieve. And we will scan this application. The PID is 2572. So yeah, the application got scanned and PE-sieve created a directory, process 2572, where it dumped the extracted implant. If we run the implant, we can see that this is exactly the injected application. And now if we run it as standalone, we see that it's no longer impersonating a calc because we just extracted the payload and it's a different PE inside the calc. So I will now run another application. This time it's Mimikatz, but it's running under the cover of Microsoft Notepad. Again, I will scan this process with PE-sieve, and we will see that this process will get extracted and this original PE. 1932. And we got another directory where the Mimikatz got dumped. And again, now we can see that it's no longer runs under the cover of Notepad. Now it's just plain Mimikatz extracted from that infected process. So, okay, I demonstrated how it can be done with the help of PE-sieve. But now let me show you how to do the same thing with the help of Holes Hunter. Let's say we know that there is some infected process in the system, but we don't know which one it is. So we cannot point directly by the PID. And for this purpose, I can run Holes Hunter. First, I will run it just with question mark without any arguments, so that we can list all the possible parameters that it can take. We can apply various filters, but this time I'm not going to apply any filter. I will just add one parameter dir, which sets a root directory for the output. So I will set the directory dumps1, and let's scan the full system, all the accessible processes with Holes Hunter. And we can see that total suspicious are 2. So let's see what is inside dump1. And yes, there are exactly those 2 processes detected. So as you can see, those techniques of impersonation cannot hide the real payload from the PE-sieve. But for sure, you are curious how it works on a real malware. So I'm gonna delete those dumps and let me start some real malware that I prepared for you. I have those things here, and those things is a banking Trojan based on the code of famous Zeus Trojan. So we can expect that it will be not only impersonating the process, but also hooking some APIs. But let's begin by scanning the full system with Hollows Hunter again, just to make sure that the system is clean. So now you can see I closed the previous two processes. Nothing is now nothing is running. Nothing suspicious is running as 0 processes are detected. Okay, so let's start the sample of those things. Let's give it the time to unpackage that and inject into the target processes. So it created 2 instances of Explorer. Those are the processes that it impersonates. Although, yeah, the presence of 3 instances of Explorer can indeed be suspicious. And here is yet another one. Okay, I think it did all what it was supposed to. The system already got infected. So now I will scan the full system again and dump the payloads into the directory dumps too. And we can see those 3 processes got indeed detected. Let's go to the directory and see what is inside. And I will check them using PE-sieve. Okay. So there are 2 samples, 2 payloads inside one process. Here is yet another instance of the same implant as here. We can guess it, but by checking the details. Here is yet another instance of this implant. And the sample, yet another implant in Explorer exe. At this time, this implant is additionally packed with UPX. And yes, because of the fact that samples packed with UPX don't keep the original tank, they have only one tank. After the imports are loaded, the names are automatically erased, and of course, we would like to have them. So PE-sieve can also provide an erasing of the imports. There is an option E, which can be run with different values. Let's run it with option A, that auto detects the most suitable mode of import recovery. Okay, let's reload it. And as we can see this time, PE-sieve recovered this import table. I think it revealed it even fully. I set it to auto detect, so it revealed it fully. We could also use the option unerased, which is a bit different. It will not rebuild from the scratch, it will only unerase the erased parts. Let's reload this sample again. Yeah. This time we have just simply unerased import names. So okay, we managed to unpack those implants. Also, what I wanted to show is that inside those directories, there are always reports which give us details on the dump, and on one report is about the scan and another report is about the dump. So we can see in the scan report where exactly those implants were found and what were the characteristics and that triggered the detection. So, for example, we can see that this implant was detected by few different scans: a mapping scan, header scan, and working set scan. And I will explain what does it mean later. Anyways, we have those implants dumped now. We could analyze them in IDA because we have now direct access to the code of the implant. It's no longer protected by the packer. But I can suspect that not only implants are injected, but there are also some hooks installed. And this is a difference between PE-sieve and Hollows Hunter, that PE-sieve detects hooks by and other patches, of course, which are also treated the same. So PE-sieve detects hooks by default. And in case of Hollows Hunter, we need to enable this detection by yet another option, hooks. And why is it like this? It's because I just wanted to make it less noisy due to the fact that Hollows Hunter scans full system. Not only it's not directed at one process, but it can scan all. If this option would be enabled by default, it could create too much noise. Because, for example, if we have some .NET applications and they use just-in-time code, just-in-time compiled code. So just this code generated by them is dynamic, and also some of the DLLs are hooked and patched. So having option hooks enabled would just get triggered at them, and we want to avoid having too much noise. So, and well, there are also some compatibility schemes. If we run, for example, an old application on new Windows, and the operating system might apply a scheme, and the scheme will also cause some patches to be installed in the application. And that's why the default Hollows Hunter scan is made in a way that it will get triggered only on replaced or implanted PEs, but hooks we have to enable manually. So at this moment, I'm gonna enable hooks. And yeah, as I said, it got triggered at one .NET application. So there is also a way to filter it out by changing .NET policy. We can change it by using switch DNet, and with question mark, we will see all the possible options. So I will use DNet 3. Now only our malware is detected, so it's good. We can search what was hooked here. And indeed, there is a lot of stuff hooked. Now in the report, we can also see yet another label, code scan, and the number of patches that the code scan found. So there are several DLLs that are patched, and we will look inside them. For example, here, functions like close socket and WSA send and send are hooked, which we can associate with the fact that banking Trojans redirect some of the APIs to their proxy so that they can steal the data. And here in user 32 DLL, we can see full list of functions hooked. Some functions also look familiar to me. For example, Zeus does a screenshot on click, so that's why functions like get cursor pose is hooked, and of course it's redirected to this implant. So on the click, the execution will go to malware, and malware will create a screenshot, and this screenshot will be later sent to the CNC. So by looking at what is hooked, we can see some patterns. For example, here, the function that imports certificate is also hooked, and it's because this is also typical for banking Trojans, that they install their own certificates and redirect the traffic to the proxy using those fake certificates. But I want to show you yet another thing. These tag files are not only used, they can be used as a text file as well, but I think the more interesting fact is that they can be loaded to various analysis tools. For example, another tool of mine, PE-sieve, supports them by default. So we can just load it to PE-sieve and browse through those tags. So every patch, we can see its original context. We can see what code was before, what code is after, and it helps to understand the full flow better and how the malware affected the original flow, where it will go next. We can also see the RVA in this dumped malware sample. So we can reconstruct this flow very easily. We can see that, okay, it goes to send, then it goes to malware implant at RVA 15 F10. So it goes here to another function. And of course, analyzing it fully would take too much time. So I leave it as an exercise for you. And we will move to another example. Just before I move, I'm gonna kill those processes. And it can be done by Hollows Hunter with the option kill. Of course, if malware has some persistence, the same sample will be executed at system restart. So it's not enough to really disinfect the system, but for now it's good enough. You will just kill those processes. And as you can see, the malware is no longer running. I will scan the system once again, and it is clean. So we can move to yet another example. And this time I would like to present you yet another tool, which I didn't show yet. And I mentioned briefly about it. So this is Unpack. Unpack has a PE-sieve inside as an engine, but yet it has different set of options. It can take an X as a parameter, so the path to the X that we want to run, and the timeout. So after the timeout finished, and the original sample will be killed no matter if it got unpacked or not. And for this, I will use, okay, let's use first QBot. So being malware analysts, often we have to start our work from unpacking the sample, because usually malware comes packed, so the outer layer is used only for evasion, and it does not contain the malicious code. So the first step is just to get the payload, and Unpack can do this for us. I will use the QBot as an example, and timeout. Let it be very small. It is in milliseconds. We can see the report, and yes, it worked. The QBot got it unpacked. So Unpack created a directory with the same name as the original sample that was unpacked. And inside we have the payload, even two payloads, because sometimes it happens that there is a chain of loading. So we have the second stage loader and finally the payload. And probably this was similar here. We have also a list of imports from one and the other samples. This was an easy case, but I have here yet another sample that is yet more interesting. So sometime in the past, me and Mark Lectic presented funky malware formats. So we analyzed some cases in which the malware didn't really come as a PE file, but it come in some custom formats with different headers, or with the header that only partially resembles a PE file. And the example of such file of such funky malware is Gauzy, which instead of using PE file and loading manually a PE file like most of the malware does, it was using a file in the custom format PX, which was like a reduced portable executable. So it had some elements of the PE header, but not all. And for example, the import table was also custom. It was different than in case of original PE. And here I want to present you that even in such cases where PE header is somehow destroyed or incomplete, or even customized and minimized, still, if there are some artifacts, PE-sieve can reconstruct the rest of the PE header basing on those artifacts, and thanks to this, the dumped payload can be loaded by typical tools such as IDA without any problems, without any external tools that would parse this custom header and rewrite it. PE-sieve will just do it in a generic way. Of course, it does not work in each and every cases, but it works in quite many cases, and it's very helpful. So let me start now. Let me try to unpack Gauzy with Unpack. let's say we will leave the timeout as is. Sometimes we will need longer timeout, but this time I think it's sufficient. Gozy, and let it go. And let's see in our log, and Gozy got unpacked too. And we have it here. So this was also a case where not only one payload was unpacked, but there was a chain of loading. So there was the second stage a loader. And finally, here we have the final payload. So this PE header that we can see is fully recreated by PE-sieve, basing on the artifacts, and the import table is also fully rebuilt from the scratch by PE-sieve, because it was in different form in the memory. The only thing that PE-sieve was not able to recreate was the entry point at which the execution started, because just there is no artifact that can let PE-sieve guess what was the entry point. Also, relocation table could not be reconstructed, but we have the most important elements that can let us still analyze this malware. Entry point we can find then later manually. We have code that we can analyze further. Maybe I will show you very briefly how we can open it in IDA. It was this one, yes. So we have here the valid code. We can even decompile it because everything got reconstructed very well. Of course, I'm not gonna analyze it right now because it would take too much time, but I just wanted to show you that PE-sieve can help you even in such situation where the payload has PE header erased or changed. So it's not just a dumper, it's more than this. So this is all for the demos. Thank you. And let's move to the next part.